Lastly, I want to talk about alerts. You're obviously not always keeping an eye on all those dashboards, requests, metrics, and so on. A common thing to do is create an alert, so you are notified when a specific action happens or if a certain condition is met. Via alerts, which you can access via the menu on the left, you can create and manage them. Let's say I'm going to create a new alert rule. The first thing that we should select is the scope, but seeing we started from an Application Insights resource, that is the scope that is automatically selected. Then we can choose the condition. It starts with the single name. That's the thing, let's say, you want your alert to be triggered on. Exceptions, failed requests, etc. are popular, but there's more if you want. For the demo, let's go with a popular one, failed requests. The threshold defines if the alert is triggered or not. For example, as it is currently set, the alert will be triggered when the failed request count is greater than 0. Dimensions then allow you to split up the alert, for example, by result code. And then we can choose how often to evaluate this rule. Let's just leave that at every minute. Dimensions allow you to split up the alerts, for example, by result code. So I want a 404 and a 500, that looks good. And I also select to include all future values, because not every possible failed response code has necessarily happened at this time. And then we can also choose how often the rule is evaluated. Let's just leave that at every minute. Let's click Next. What we can do here is create the action, or rather the group of actions we want to see executed when our condition is met. Let's create a new action group. Say we want to be notified by email. So I'm going to name the group Send Mail for Dome Train for the demo. And on the notifications group, I choose to email myself. All right, let's click OK. Email admin, let's say. All right. Optionally, you can also trigger other things, like triggering a logic app, a webhook, or an Azure function. We don't need that at the moment. Can add tags, we don't need those either. So let's click Review and Create. This is all looking good. Now let's click Create now. Onto the detailed section, it seems like I have to input an alert rule name. So let's name this Demo Alert Rule. I'm not going to add tags. And let's create it. All right, we've got a new rule. Now let's send a few requests that will fail, for example, to this does not exist. This should result in me getting some email. So I've waited a bit, opened my mailbox, and indeed here is that mail. Our demo alert rule was triggered for our app service. There's more that App Insights can do. It probably warrants a course on its own, but what I've shown you here should already go a long way towards a reliable and performant application. This section was about debugging, logging, and monitoring. We started with learning about remote debugging on Azure. This allows you to attach the Visual Studio Debugger to a running instance of your API on Azure, enabling you to inspect code, set breakpoints, and view variables as if debugging locally. Almost all applications log messages, as this is essential for monitoring application behavior and diagnosing issues. To be able to view your application logs on Azure, you need to enable logging to the file system. When logging to the file system is enabled, the logs can be viewed in real time using the log stream feature or downloaded via Kudu. Blob storage logging is mainly useful when you need to integrate your custom apps with those logs for managing and/or analyzing them. Then we looked into Application Insights. Application Insights is a feature of Azure Monitor that provides detailed telemetry data about your application, including logs, metrics, requests and response data, and errors. It goes beyond what the log stream or downloadable logs via Kudu offer. It offers various tools for analyzing application health and performance. It needs to be specifically enabled at level of your app, but as you've seen, it's a matter of a few lines of code. Once that is done, your application will start to send telemetry data to Azure, more specifically to a specific Application Insights resource and related Log Analytics workspace. Once you have those App Insights logs and they are available through your Log Analytics workspace, you need a way to analyze and query them. That's where KQL or Kusto Query Language comes into play. KQL is used to query data stored in a Log Analytics workspace, allowing you to filter and analyze logs and metrics. If you're looking for your application logs, they are stored in the traces table, and various other tables are available for different types of telemetry data as well. Next to looking at those logs, Application Insights also provides tools for monitoring application health and performance. We looked into those as well. Lastly, you learned how to set up an alert to notify you or trigger actions when certain conditions are met, such as failed requests or exceptions. And with this, the section is done. But there's more to monitoring and logging than your own code. The Azure platform itself also generates logs, metrics, and so on. These too are important to monitor the overall system health. Let's dive into that in the next section, monitoring Azure resources. In the previous section, we focused on application level monitoring and debugging. That's very important, but seeing we're on Azure, there's another part that requires monitoring, the Azure resources themselves. Combined with the application level monitoring options from the previous section, this should provide you with all the tools and information you need to end up with reliable and performant apps. Let's dive in. I've mentioned Azure Monitor before. It's a solution to monitor resources and applications for things like performance, availability, and overall health. Application Insights is one of its features, focused on application level monitoring, but Azure Monitor is broader than that. It can monitor a variety of resources, from apps over operating systems and databases to virtual machines and security events. And it doesn't even matter that they're on Azure. They can be, but your resources might as well live on premises or with other cloud vendors. So the story starts with the different data sources. The first data source type are applications and related workloads like SQL Server workloads. We looked into this application type data source extensively in the previous section. The second data source type is infrastructure. Think of operating system event logs or logs coming from your containers. Then we have the Azure platform data source type. That's interesting for us because it's through this that monitoring of Azure resources, like our resource groups, our app services, etc., is enabled. And lastly, custom sources are also supported. Support for this is enabled via the Azure Monitor REST API and Data Collection API. These sources can thus be anything, really, from your own on-premise solutions to things that live at other cloud vendors. So these are the sources. From these sources, various types of telemetry data are collected in one common data platform. Typically, you'd speak of 3 different types of telemetry data: metrics, logs, and traces, or rather distributed traces. Let's start with the first one. Metrics are numerical values that describe an aspect of a system at a particular point in time. For example, the total amount of memory used. We inspected that in the previous section. That was a good example of a metric. CPU utilization is another typical one. The second type of telemetry data are logs. Logs are essentially recorded events, information from your application, from a system, in a certain structure or completely free form. We looked into quite a few of those as well. The third type is tracing or distributed tracing. This is what allows you to follow a request as it travels through different services and components. We looked into that as well when we looked into the end-to-end transaction details when we inspected a request in App Insights. And I do have to add a fourth one here for completeness sake: changes. We are not using it, but if you happen to use Azure's change analysis service, you can get a list of recorded changes from Azure Monitor. These represent series of events that happened. Think about changes in app settings, changes you made to an Azure function or web app, or a code update you deployed. So these different types of telemetry data are then combined into one common data platform with a common structure, so they can easily be consumed by a variety of consumers. Like that, all that telemetry data can be analyzed, visualized, correlated and so on as if it was one. Think of Power BI, all kinds of dashboards, app insights, metric explorer, or your own custom solution. And with that, you know what Azure Monitor is and what it can do. We already covered the application level metrics previously. I won't go into detail on the custom sources, as those are less relevant as a full-on Azure developer in my opinion. However, seeing that as an Azure developer, we are focused on Azure's platform as a service offering, looking into the Azure platform sources is important. So let's dive into that next.